This question is related to polarization of the light. Explain the difference between the polarized and unpolarized light. So what is the difference between the polarized and unpolarized light? Basically, polarized light, which is having a vibration in a single plane, and that the vibration is perpendicular to direction of energy transfer. And for unpolarized light, the vibration is like different vibrate in different directions, many directions, and that also the direction of a vibration is perpendicular or 90-degree to energy transfer. But if we use the term plane for polarized light, if we say oscillation or vibration in a single plane, then that plane include the propagation. So light which is having only one component of a vibration, as like example, if I draw this, so only one component of a vibration, and this is the black line, the arrow is representing a direction of energy transfer. Where unpolarized light will have multiple components. So multiple components are there, and all these components are perpendicular, or all these vibration are perpendicular to direction of the wave. So wave direction, example towards the right hand side, but polarized light is having only one component, and unpolarized light will have many components. And that's why, because unpolarized light is having many components, so it will have a higher intensity as well. Like it will appear to be bright. So the answer here, you will mention like only one vibration, and that vibration is perpendicular to direction of energy transfer. Here, multiple vibration, and all the vibrations are 90-degree or perpendicular to energy transfer. The second part, two photographs of a same car windscreen were taken under same condition. One of these was taken through a polarizing filter. Like one of the image or one of the picture we took by polarizing filter. Explain which photograph was taken through polarizing filter. So basically what will happen, light which will have multiple component of a vibration. So which one is taken with a polarizing filter? It is obvious B is taken with a polarizing filter. Why? Because B is giving us only one component. Here we see the reflection also, as well as partially we can see the object inside. Here we mostly, because it cut off the reflection, and mostly we see what is inside. So reflected light is partially polarized. What is the meaning of partially polarized? Like it will have the component, like when the light is reflected, it will have partial, like small other component is there, but majority of them will be horizontal. So reflected light is, as a reflected light is absorbed or blocked by the filter, so what we will able to see, will able to see the object which is inside. So like example, the light which is having multiple components of the vibration. So when this light bounce off, it is partially polarized. Partially polarized means like it will have uh, other components as well, but a small proportion. So that is partially polarized. That's why we are able to see the reflection here. But if you observe the same windscreen through the polarizing filter, so when the light strike and bounce off, and it will have the, it is also partially polarized. But what we are observing through a polarizing filter. So like example, this is a polarizing filter through which we are observing. So if the plane of the polarizing filters, like example, are vertical, so only vertical component is able to pass, and the the perpendicular component is or other component are absorbed. So it will only allow the vertical component of the light to pass. That's why it will give us a clear image. But here what happened? So when the light strike, it is partially polarized. So using a polarizing filter, when you observe, you'll see a clear image because only one component is observed. Here, multiple components are observed.